All right, listeners, ready for this deep dive? We're talking about a planet shaped like a cosmic football. I mean, can you believe this thing? And get this, there's a missing methane mystery. AND. The James Webb Space Telescope is involved. Buckle up.
This is a big one. We're talking about a discovery that's making scientists rethink what we know about planets, how they form, how they evolve. It's pretty incredible stuff.
So we're talking about WSP-107b, right?
That's right.
This exoplanet, it's about, 210 light years away?
How about that? Yeah.
Which sounds ridiculously far.
It is.
But in the grand scheme of things.
Yeah, cosmically speaking, it's right next door.
Right next door.
Yeah.
But here's the thing. This planet is huge. It's almost the size of Jupiter. But it's incredibly light. Like, how light are we talking?
We're talking 10% of Jupiter's mass. It'd be like finding a balloon the size of a house, but it only weighs a few pounds.
How does that even work? What could possibly explain that?
That's the million-dollar question, isn't it? See, we're talking about a gas giant here, a planet that's supposed to be mostly, well, gas. But WASP-107b's density is so low, it's so low that it suggests something else is going on with its composition, something unusual. It's like comparing a bowling ball to a giant beach ball. Same size, but vastly, vastly different weights.
Okay, so we've got this gigantic, fluffy planet, basically.
Practically, yeah.
So what's the deal with this missing methane? The article mentioned that, and it seemed like kind of a big deal.
Oh, it is a big deal. It's a crucial detail, actually, because methane is like a signature ingredient for gas giants. Think of Jupiter. Think of Saturn, those vibrant colors. That's methane in their atmospheres.
Oh, really?
Yeah.
I never knew that.
Oh, yeah. It forms easily in the cold upper layers of these planets.
Huh. So WSP-107b is like a cake missing its key ingredient. Something's not adding up here.
You got it. And that's what's got everyone scratching their heads. The fact that it seems to be lacking methane, it suggests that something unusual happened, either during its formation or maybe its evolution. It's possible the planet formed in an environment that was different than we expected, maybe further out from its star where it was colder, or there could be processes happening in its atmosphere that are breaking down the methane faster than it can form. We just don't know yet.
And this brings us to, I think, the biggest mystery of all, which is, why is this planet so lopsided?
This is where it gets really, really interesting. This is where the James Webb Space Telescope really, really comes in. They're using a technique called transmission spectroscopy. And basically what they're doing is they're analyzing the light passing through the planet's atmosphere as it moves in front of its star.
So they're analyzing its light, like its fingerprint almost.
Exactly. You got it. Imagine trying to figure out what's inside a stained glass window, but you can only look at how the light shines through it.
That's incredible, but how does that explain this weird shape?
Well, it's all about the details. See, this technique, it allows scientists to compare the eastern and western hemispheres of WASP-107b's atmosphere. What they found was a significant difference, especially in the upper layers. And that difference, that's what points towards an uneven distribution of gases.
Okay, that's wild. The article also mentioned something about WASP-107b being tidally locked to its star. What does that even mean, and how does that factor into all of this?
Okay, so tidal locking. That means that just like one side of the moon always faces Earth, one side of WASP-107b always faces its star. Now imagine one side of a planet perpetually baked by its sun while the other remains in constant darkness.
So one side is basically getting blasted with heat all the time, and the other side is in perpetual darkness. That's got to do something to a planet's atmosphere, right?
Oh, yeah, absolutely. That constant heat on one side can create some pretty dramatic atmospheric effects. It's like comparing Earth's scorching Sahara Desert to the icy Arctic. Totally different environments just because of temperature variations. Now magnify that to a planetary scale with constant, intense starlight. And you can start to see why the day-side atmosphere of WASP-107b might behave very differently from its night side.
Okay, I'm starting to get the picture here, but here's the thing. Even with that constant heat, the article said that WP-107b is actually cooler than many other exoplanets we've observed. And it's not just the heat, right?
Yeah.
There are a few different theories about why this planet is so lopsided. What else could be going on?
You're right. There's rarely one simple answer in the cosmos, right? The planet's rotation, even though it's tidally locked, it could be playing a role. It's like spinning a water balloon. The water inside wants to move outward, creating a bulge. Now imagine that with a planet's atmosphere. The spinning could be contributing to this uneven distribution of gases that we're seeing.
So we've got this constant heat source, we've got a slow rotation. It's like a cosmic recipe for a lopsided planet. But the article also hinted at something about magnetic fields. What's the deal with that?
Ah, yes, the magnetic field. That adds another layer of complexity.
Okay.
We know stars have powerful magnetic fields, and planets can have them too. It's possible that the magnetic fields of WASP-107b and its star are interacting in a way that's contributing to this lopsided effect. Imagine like a cosmic tug of war with the magnetic fields pulling on the planet's atmosphere.
Okay, so we've got a cosmic heat lamp, a slow rotation, A and D, a magnetic tug of war, all potentially shaping this one planet. This is mind-boggling.
It really is, and the fact that we've never seen anything quite like this in our own solar system makes it even more intriguing. It challenges our assumptions about what's normal for a planet, you know? Even the researchers themselves have said that this discovery raises more questions than answers, and they're eager to investigate further.
Which makes sense, because this is basically like studying a puzzle with half the pieces missing. But if WASP-107b is so far away, how can we even begin to solve this mystery?
That's where the James Webb Telescope's power truly shines. While 210 light-years is a vast distance, it's relatively close in astronomical terms. And the telescope's advanced instruments are providing us with incredibly detailed observations. Remember transmission spectroscopy, the technique we talked about?
The one where they analyze the light passing through the planet's atmosphere.
Precisely. But there's more to it. By carefully studying the subtle variations in the light as it passes through different parts of WASP-107b's atmosphere, scientists can start to map out its composition in more detail. They'll be looking for different elements, different molecules, which will give us clues about the planet's formation, its temperature, even its weather patterns.
So it's like piecing together a multi-layered puzzle. Analyzing the light, understanding the potential forces at play, and comparing WASP-107b to other exoplanets we found.
You've got it! This discovery has opened up a whole new avenue of research, and the scientific community is buzzing with excitement about it.
It's amazing to me how much information scientists can get from a tiny flicker of light from trillions and trillions of miles away.
It really speaks to how incredible human ingenuity is. And this is only the beginning. Researchers are already planning on using the James Webb Telescope to take an even deeper dive into WASP-107b's atmosphere.
Deeper how? What more can they even learn at this point?
Well, they're hoping to create a more detailed 3D map of the planet's atmosphere. They're going to do that by looking for even subtler variations in the light passing through it. Imagine trying to understand the currents in a vast ocean, but you can only see the surface. Now imagine you could suddenly see beneath the waves. You'd gain a whole new understanding of how those currents flow and interact. That's what they're trying to do with WASP-107b. Go beyond the surface and delve into the intricate workings of its atmosphere.
Okay, so it's like upgrading from a regular map to a topographical map that shows all the hidden valleys and peaks. Gotcha. But WASP-107b is just one planet, right? How does studying this one oddball planet help us understand the bigger picture of how planets form?
That's the million-dollar question, isn't it? Every time we find a planet that breaks the mold, like WASP-107b does with its missing methane and bizarre shape, it challenges our existing theories. It tells us that we need to learn more about the processes that govern how planets form and evolve.
So each new discovery is like adding another piece to a giant cosmic jigsaw puzzle.
Exactly. And the more pieces we find, the clearer that bigger picture becomes. What if lopsided planets are more common than we think? What if this missing methane phenomenon points to a whole new category of gas giants that we haven't even considered yet?
That's both really exciting and also kind of terrifying to think about. Like, what else is out there that we haven't even imagined yet?
It's the thrill of the unknown, right? But it also highlights why research like this is so important. The more we learn about the vast diversity of planets out there, the better we can understand our own place in the cosmos.
It's a good reminder that we're just a small part of something much, much bigger. Well, we are coming to the end of our deep dive here. So as we wrap up, what's the one thing you would want our listeners to take away from this whole lopsided planet saga?
For me, it's the power of curiosity. WSP-107b is a perfect example of how a single, seemingly bizarre discovery can open up a whole new realm of scientific inquiry. It reminds us to stay curious, to keep asking questions, and to never, ever stop exploring the universe around us.
Well said. And who knows? Maybe someday we'll be diving deep into the mysteries of an even stranger, even more lopsided planet. Thanks for exploring with us.